So I hope you had a chance to try this worksheet if you found it on my website, and if you didn't, you can go to my website, download it, and try it before you look at this video. But this is just going over all the hydrocarbon derivatives you can see in an intro to organic course. So this is just seeing what type of groups we have attached to the main chain and then naming them from there. So if you have a halogen attached to your main chain, you want to name it as a prefix along the chain. And you would, if you have more than one, you'd start naming it just how you would a methyl, an ethyl, or a propyl group. If you have an alcohol, you have an OH group somewhere on the chain, and you would indicate where it is by putting the number, kind of like how you would a double bond. If you have a aldehyde, you are going to see a double bond to carbon, and then that same carbon will be single bonded to one hydrogen. And then the suffix there, you just change it to -al. If you have a ketone, instead of having a hydrogen here, you're just attached to the carbon. So essentially you'd have this carbon double bonded with an oxygen somewhere on the chain. If it's not on an end, you would also say where it is. Now, if you're double bond carbon and oxygen, and that carbon is attached to an OH group, then you have a carboxylic acid, and you would change your ending to oic and add on acid. And if you have an ester, that means instead of a hydrogen attached to that oxygen, you have another carbon chain that came from the alcohol, and that chain gets named first, and then your main chain gets named next with the 8 at the end. And then the last one is amine. And if you have an amide group, that just means you have an NH2 group somewhere along the chain. And same idea, you need to say where it is. Now, if you are in chemistry 30 in specific, you would not need to know the aldehyde, the ketone, or the amide. The amide comes up a little bit when you look at polymers, but in general, when it comes to naming and drawing, you would not be asked that. So moving on from here, we can practice doing some of that naming. If you have that chlorine group, you want to see how many carbons you have in your main chain. And because it's on carbon 1, you can just call this chloro, and then 4 butane. This next one, that OH group is on carbon 1 because we would number to give this the lowest number for the OH group. And so we'll number going right to left. So this would be butane, and then 1-al, showing that it's on carbon 1. This next one, we have that suffix of al just because of that hydrogen on the end, and just naming how many carbons we have. So this is a 3, 4, 5, and 6. This would be hex and al. This next one, we have that ketone now, and we have on our chain, it doesn't matter if we go from left to right or right to left, 1, 2, 3, 4, 5, 6, 7. Either way we go, we'll see that that double bond oxygen is on carbon 4. So this would be hept for 7 on your main chain. So heptane, and then you would say -4, and then ONE to indicate that you have your ketone. This last one is a carboxylic acid. This is carbon 1. Carbon 1 is always attached with the acid with that OH group and that double bond oxygen. So 1, 2, 3, 4, 5, 6. This would be hexanoic acid. Going down to the drawing these, get this a bit bigger. Drawing these ones, looking at this first one, you have 2-bromobutane. Now, same thing, if it doesn't tell you what to use, well, this one's saying conduct structural, but I'm just going to change it to line diagram, and hopefully we can get there just because it's faster. So if it's butane, we have 4 carbons on the main chain. So 1 to 2 to 3 to 4, and on carbon 2, you will see that bromo group or bromine. Propane 2-al, propane is 1, 2, 3, and then on carbon 2, you would have an OH group attached. The but-al, in this one, if it's butane, you have 4 carbons, so 1, 2, 3, 4. And then on carbon 4 is where you see that double bond oxygen single bonded to a hydrogen. Number 9, ethanoic acid. Ethanoic, we would just have 1, so this would be carbon 1, carbon 2 for 2 carbons, and then we have an O and an OH group on the end. And then this last one, ethyl propanoate. Propane is our chain that's attached to the double bond to oxygen, and that's 3 carbons, so 1, 2, 3, so 1, 2, 3. double bond oxygen, single bond to an oxygen, which is connected to an ethyl group. So 1, 2. Lastly, we have a few more. Some of these you definitely would not see in Chemistry 30, but they are challenging and you would see them in some intro chemistry organic courses. So looking at what we have here, we have this group on the end. That is our carboxylic group, but you also have an OH group on here. So if we're going to name this one, we'd have carbon 1, 2, 3, 4, and 5. So on carbon 5, you would call that OH group a hydroxy group. So it would be 5-hydroxy, and then pentanoic acid. The next one, same idea. We have that carboxylic acid. So carbon 1, 2, 3, 4, 5. And then you have an amide group. So you would call that an amino. So 5-amino. And then we'd have pentanoic acid. I hope you can read my writing here. And this last one, you have that OH group on carbon 1, and then we'll have carbon 2, 3, and 4. So on carbon 4, you have a chlorine group, so chloral. And then 4 carbons would be butane, so butane, and then -1, all showing that you have that OH group on the first carbon. So as always, I hope you found this helpful. If you did, please subscribe. If there's any other video I could do for you, just let me know in the comments. If you didn't have a chance to try this worksheet, please check out my website. Anything highlighted in yellow are worksheets you're able to download, try, and then there's a video to go through it. Thank you for watching.